There are two fundamental shifts that are happening at the same time. In 1964, the IBM System 360 introduced the world to the concept of IT. The IT industry as we know it. Introduced the idea of general purpose computing. For the last 30 years, we've had the benefit of Moore's Law. An incredible phenomenon. Without changing the software, the hardware can continue to improve in an architecturally compatible way. And the benefits of that software doubles every year. Moore's Law made it possible for us to continue to drive down cost, democratizing computing as we know it today. But we know now that the scaling of CPUs has reached its limit. We can't continue to ride that curve, that free ride. The free ride of Moore's Law has ended. We have to now do something different. We started our company to accelerate software. Our vision was there are applications that would benefit from acceleration if we augmented general purpose computing. We take the workload that is very compute intensive and we offload it and we accelerate it using a model we call CUDA, a programming model that we invented called CUDA that made it possible for us to accelerate applications tremendously. Real-time computer graphics was made possible because of Nvidia coming into the world and make possible this new processor we call GPUs. The GPU was really the first accelerated computing architecture running CUDA, running computer graphics, a perfect example. We democratized computer graphics as we know it. 3D graphics is now literally everywhere. And so over the last 30 years, we've been on a journey to accelerate one domain of application after another. Today, we accelerate so many important industries. Litho is fundamental to semiconductor manufacturing, computational lithography, simulation, computer-aided engineering, even 5G radios that we've recently announced partnerships with, that we can accelerate the 5G software stack, quantum computing, so that we can invent the future of computing with classical quantum hybrid computing, Parabricks, our gene sequencing software stack, QVS, one of the most important things every single company is working on is going from databases to knowledge bases so that we can create AI databases. Using QVS, we can create and vectorize all of your data. These acceleration libraries now cover so many different domains that it appears that accelerated computing is used everywhere. But that's simply because we've applied this architecture, one domain after another domain, that we've covered just about every single industry. Now, accelerated computing, or CUDA, has reached the tipping point. Every single time I've come to India, I've had the benefit of talking to you about deep learning, had the benefit of talking to you about machine learning, and I think it's very, very clear now the world has completely changed. The first thing that happened, of course, is how we do software. Our industry is underpinned by the method by which software is done, the computer model that we understood quite well. And it, of course, created one of the largest industries in the world, right here in India, the production of software. Coding, programming became a whole industry. However, that approach of developing software has been disrupted. It is now not coding, but machine learning. This way of doing software, notice, is based on fundamentally machine learning. And we have gone from coding to machine learning, from developing software to creating artificial intelligence, and from software that prefers to run on CPUs to now neural networks that runs best on GPUs. This, at its core, is what happened to our industry in the last 10 years. We dedicated ourselves to advance this field. And so this is what we now build. This is what a GPU looks like today. This is Blackwell. Incredible system that is designed to study data at an enormous scale. We have now learned the meaning of so many different types of data. We have learned to represent, how to represent information in so many different modalities. Not only have we learned the meaning of it, we can translate it to another modality. So one great example, of course, is translating English to Hindi. Translating English, large body of text, into other English, summarization, from pixels to image recognition, from words to pixels, image generation, from images, videos, to words, captioning, from words to proteins used for drug discovery, from words to chemicals, discovering new compounds, from amino acids to proteins, understanding the structure of proteins. In the last couple, 2-3 years, the number of generative AI companies around the world, tens of thousands, tens of billions of dollars have been invested in this field, all because of this one instrument that made it possible for us to study data at enormous scales. In order to build the Blackwell system, of course, the Blackwell GPU is involved, but it takes 7 other chips. TSMC manufacture all of these chips, and they're just doing an extraordinary job ramping the Blackwell system. This is Blackwell is in full production, and we're expecting to deliver in volume production in Q4. This is NVLink, and it goes across the entire back spine of a rack of GPUs. And these GPUs are all connected from the top to the bottom using NVLink, driving these incredible SerDes, the world's longest driving SerDes for copper. And it connects all of these GPUs together. 72 dual GPU packages of Blackwells, 144 GPUs, connected together so it's one giant GPU. This is connected to this switch. And this is one of the most advanced switches the world's ever built. Now, all of this together represents Blackwell, and then it runs the software that's on top. This is what NVIDIA builds today. Those of you who have known us for a very long time, it's really quite surprising how the company has transformed. But literally, we reasoned from first principles how computing was going to be done in the future, and this is Blackwell. And what we're trying to do is to learn larger and smarter models. It's called the scaling law. The scaling law comes from the fact that the empirical observation and measurements that suggests the more data you have to train a large language model with, and therefore the correspondingly large model size, the more information you want to learn from, the larger the model has to be, or the larger model you would like to train, the more data you need to have. The second thing that we've discovered recently, and this is a very big deal, after you're done training the model, you give it a prompt, and the AI processes through a very large neural network and produces a sequence of answers. In the future, and starting with Strawberry, we realize that, of course, intelligence is not just one shot, but intelligence requires thinking. And thinking is reasoning, and maybe you're doing path planning, and maybe you're doing some simulations in your mind. You're reflecting on your own answers. And so as a result, thinking results in higher quality answers. And we've now discovered a second scaling law. And this is a scaling law at a time of inference. The longer you think, the higher quality answer you can produce. And so that's where thinking, reasoning, planning comes in. And the more you compute, the higher quality answer you could provide. And so we now have 2 fundamental scaling laws that is driving our technology development. First for training, and now for inference. The number of foundation model makers has more than doubled since the beginning of Hopper. There are more companies that realize that fundamental intelligence is vital to their company, and that they have to build foundation model technology. And second, the size of the models have increased by 20, 30, 40x the amount of computation necessary to train these models because of the size of the models, but also multimodality capability, reinforcement learning capability, synthetic data generation capability. The amount of data that we use to train these models has really grown tremendously. That's one, and then the other reason, of course, is that Blackwell is also used for generating tokens at incredible speeds. And so together, all of these factors has led to the demand for Blackwell being incredibly high.